Hello everyone. This is the video to talk about scaling. Help you guys out with this scaling lab number 4. So I was just gonna do the first example or two, help you guys out. So with maps, diagrams, models, blueprints, all that, it's important that you have a consistent ratio with your measurements. If you don't always have the same number of inches on your diagram, meaning the same number of feet or miles or whatever on your map in real life, then it becomes much less useful. I didn't pick this example here, but the idea is that if a modern Barbie doll has all these different number of inches, so this for their height, this for their chest, this for their waist, all those need to transfer to with the same ratio the measurements for the so-called real live Barbie doll Valeria Lukianova. Once again, didn't pick this example. Uh, don't know how to say all those names. But so let's go through the process of like how do we turn all these measurements into real life measurements using a constant ratio. So the first bit is just we need to get a consistent unit for the real life person so we can get the ratio. Basically, you can't do math with 5'7" easily. You want to get it all into inches so that you can do that appropriately. So got Valeria, who's 5'7", and we should know by now that 5 feet is the same as 12 inches for every 1 foot, or that'll give us 60 inches. And then we can use this little symbol for inches. Add that to the 7 that we had left over from the start, and we get that her total height is 67 inches. Once we've done that, we can construct a ratio that's going to, or a fraction that's going to transfer between all of the Barbie's measurements to the theoretical life-sized Barbie that we've got over here. Basically, our ratio will want to go from 67, the 67 inches of Valeria from the 11.5 or 11.5. You can stick the 1/2 in a calculator. It'll tell you the decimal if your brain works better with that. Um, so we've set up a fraction that's Valeria divided by Barbie, both of their heights, in order to come up with a ratio that transfers from one to the other. And so the way the book tells you to do this is do some cross multiplication. So the next bit, plug in 67 here, is to, well, okay, so that's her height. Want to find the waist size, and we know that the Barbie doll has waists that are 3.5 inches wide. So we want to equate that ratio. I put Barbie on the bottom, so we want to put Barbie's waist, in this case, on the bottom. So ratio of their heights has to match the ratio of their waists. And so we don't know Valeria's waist yet. We want to solve for that. So we can cross multiply. Multiply 3.5 over here, multiply 11.5 for that. So we get 67 times 3.5 is equal to 11.5 times x. X is just a placeholder variable. So imagine that's just, it's all it is it's a number that we don't know yet. So we treat it like any other number until it's time to solve for it. Can get 67 times 3.5, 200, and get 234.5. is equal to 11.5 times x. So then x is just a number, and if we have 11.5 times a number is equal to something, oh, let me get rid of that, then we can divide both sides by 11.5 and solve for that number. So the same way if we said 2 times 5 is 10, if we divide both sides by 2, we could find the original number, which is 5. So divide our 234.5 by 11.5, and we get 20.39. Etc. And that is going to be the waist width of of the real life Valeria if she was perfectly matching Barbie doll's dimensions. Whether or not that's realistic, leave that up to you. Um, do, do, do. So that's the way the book teaches you. Now, but if you're having to do a bunch of the same process here, first we're asked. Actually, let me finish this first. First, we're asked to weight size and round to the nearest inch. So 20.39, 20. Look at this decimal. Look to the right of it. That's less than 5, so we're rounding down to 20. So we should be able to plug in 20 right here. But if now we're asked for the hip size of Valeria and the foot size of Valeria and so on and so forth, if we're having to do a bunch of these in a row, what we can instead do is construct a ratio to use every time. So take this 67 over 11.5, and that is the ratio that if we, because we put Valerie's on top and the Barbie doll on the bottom, that is the ratio that will turn any of Barbie's dimensions into Valerie's dimensions. It's kind of like the unit fraction method, but if I just do 67 divided by 11.5, we get 5.83. Let's keep 3 digits for a good amount of accuracy. So 5.826 becomes 5.83. And that then, whatever measurement we get, should transfer from Barbie to Valerie. So if I take same thing we just did, but let's say, let's do the waist again. So let's say I want to go from waist of Barbie to the real life dimensions, so called. So I would just take that 3.5 dimension, multiply by 5.83, oops, and get approximately the same answer as we got last time. And indeed, it would round the same 20 inches that we got right here. So, but once you have that ratio, you can repeat that multiplication process for the hip, the foot, etc. And that can be a quicker way to do it when you have to do the same thing, go from Barbie to Valerie a bunch of times in a row. All right, hope that's useful. See you guys next time.